I've got a brand new lab for us to work with the default information originate command. We're going to get to that here in the next few minutes. I want to clarify something though, and I'll do it in the wording of the book as well. We could create a stub or a total stub area in this scenario and the one we're about to look at, but for reasons that will come clear to you as you learn to configure those in your ICND2 and further studies, you may choose not to. You may just want to send these routers a default route and be done with it. Well, that's what we're going to do in this particular lab, but I wanted to make that clear that using the default information originate command does not itself make this area a stub area. You've actually got to go in and put area 23 stub, something like that, and then go from there. So what we're doing here is just sending routers 3 and 4 a default route, because if these 3 routers are on the same segment, which they are in this lab, I've already got the adjacencies up, router 4 is up and running, and we'll verify that in just a moment. But here, router 2 is the outside interface, if you will, to the entire OSPF network. We could have 50 routes out there, and maybe we don't want routers 3 and 4 to have a huge routing table when all they need is a default route. So let's generate one and send it to them with the default information originate command. Sometimes the trickiest thing with default information originate is typing it. This isn't typing it. It's not that tricky. I'm not misspelling it that badly. Let's take a look at this. You can see that now there are 2 neighbors, and one of them, their ID is 4444, so that tells us what about router 4, that it had a loopback on it when I added it to the OSPF network. We also see DR other. We mentioned that a couple of times, and we saw it during the adjacency process between 2 and 3, but the adjacencies are completed now, and here router 4 has been named a DR other because it is other than the DR or BDR. There is no new DR BDR election, by the way, when you add a new router to the segment. That doesn't happen. The only way to have another election is to reload a router or a clear process. We saw that with earlier in lab. And also, if you reload the DR or BDR, you're going to have an election for that missing router. So let's go ahead and move forward here. And we'll go with default information originate. The dash goes there. Sometimes that's the hardest thing to remember. And originate, so we don't have too many options here. And we got a couple here at the end, but we see the CR now, so we know the default information originate is by itself a legal command. So, that always option looks odd because look at that description. Always advertise default route. Well, why wouldn't I want to do that in the first place, right? Why aren't I doing that with default information originate? Of course I want to advertise it. That's why I'm doing this. So let's go ahead and use default information originate. And we'll go down to router 3. And we don't get anything when I look at the OSPF routes. And by the way, this is a nice filter because as your tables get bigger, as your studies get more complex, these tables are going to get big. You're eventually going to have routing tables that will not fit on one screen like this in lab work. And there may be times where you just say, you know, I just want to see my static routes, or I just want to see my OSPF routes, or I'm tired of looking at that code table and I don't want to see that either. So when you run show IP route and then run it with iOS help there, you can see you can look at a particular network, you can look at all your BGP routes. That's a CCNP topic, by the way. There's EIGRP, there's OSPF, there's static. So you can really filter it out when your table gets large and you just want to look at one type of route, just run that one command. But we see here that we don't have any OSPF routes, and we would expect that default route to be an OSPF route. And when we ran the full show IP route command, we didn't see a default route in there either. So something funny is going on here. What is it? Well, here's the deal. We were kind of laughing about that always thing at the end of default information originate. Well, what that means actually is to advertise a default route even if you don't have one. That's really always. If you use default information originate, you will advertise a default route to your OSPF neighbors if you actually have one in your local router's routing table. But that may not be the case. So instead of writing one, we're going to let OSPF generate it with the always option. So again, just to clarify, default information originate will allow your router to advertise an OSPF default route if it has one in its routing table. If it doesn't and you still want to generate one, you need to use the always command on the end of it. And there she is. And also note that asterisk is back. And of course, we know what that is. That's candidate default. It's not just for static routes, because now we have an OSPF route. And there it is. That's our typical default route. And it's pointing to router 2's Ethernet 0 interface. And that's it. And if you're wondering what that E2 is, we're going to go into that in your ICND2 studies. We got to stop somewhere. But let's go down to 4. And just run show IP route OSPF, and there it is. That's exactly how default information originate works, and you know the tricky little always option at the end of it. That concludes this particular video. On the next one, we're going to look at the passive interface command. And you might be wondering why we would want an interface to be passive if it's running OSPF in the first place. We'll discuss that a little bit on the very next video. I'll see you there.